In this video, we are going to solve question number 7 to 12 from exercise 3.3 matrices chapter. So let us start with the 7th one. The first sub question is, show that the matrix A, which is a 3 by 3 square matrix, is a symmetric matrix. And the second sub question is, show that the matrix A is a skew symmetric matrix. So let us begin with the first one. So before we begin with the solving of this question, let us understand what is a symmetric matrix first. A square matrix A is said to be symmetric if A transpose equal to A, which means AJI, you can see we have interchanged the number of rows and columns, is equal to AIJ for all possible values of I and J. So here it means that if we take the transpose of a given matrix, so the transposed matrix should be exactly identical to the given matrix. So for example, this is the A matrix given over here. So let me take its transpose starting one column by one column. So I'm going to take the first column and change it to first row. So 1, minus 1 and 5, the column elements have become the row elements now, that is 1, minus 1 and 5. Now I'm going to change the second column as second row. So here minus 1, 2 and 1 has become minus 1, 2 and 1. Similarly, I'm going to change this third column as third row. So the column elements 5 and 3 have become the row elements 5 and 3. Now observe carefully the A transpose and A. Now the first column is absolutely same as the first column. The second column is same as the second column. And third column is same as the third column. You can also compare it row wise. That is, first row is equal to first row, second row is equal to second row, and third row is equal to third row. So these kind of square matrices where A transpose will be equal to A are called as symmetric matrices. So let us write here. Since A transpose is equal to A, the above square matrix is a symmetric matrix. Now let us move on to the second sub question. Show that the matrix A, which is a 3 by 3 square matrix, is a skew symmetric matrix. So we have to understand two conditions for a matrix to be skew symmetric. The first condition is a square matrix is said to be skew symmetric matrix if A transpose is equal to minus A, which means that when we take the A transpose of a given matrix, whatever elements we have of this matrix A, the elements of matrix A transpose should have the opposite signs. For example, here we see we have a positive 1. So A transpose should have a minus 1. Now here it is minus 1. So A transpose element should be plus 1. So that is the first condition. And the second condition is all the diagonal elements of a skew symmetric matrix are 0. So let us focus on the second condition later. Let us take the A transpose first of A, starting with the first column turning into first row, now the second column into second row, and finally the third column into third row. Now let us compare all the elements of A transpose with A. Now 0 stays the same, we have 0. Now plus 1 has become minus 1, minus 1 has become plus 1, minus 1 is plus 1, 0 stays the same, plus 1 is minus 1, plus 1 is minus 1, minus 1 is plus 1, and 0 stays the same. So here each and every element of A transpose is minus of A, means all the elements of A transpose have the opposite signs as compared to the elements of A. And the second condition is all the diagonal elements, so if we look at the diagonal of this matrix, are 0. So the diagonal elements of A are also 0 here, and A transpose are also 0. So once you get these two observations, we can say that since A transpose is equal to minus A and all the diagonal elements are 0, the given matrix is a skew symmetric matrix. Now let us move on to the 8th question. For the matrix A, verify that A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. So let us focus on the first sub question. Now here, since we have to verify that A plus A transpose is a symmetric matrix, which means we have to first find A plus A transpose and then find out the transpose of this entire term. So let us begin by finding the A transpose first. So this is the A matrix given in the question. We are going to take its A transpose, that is the first column has become the first row and the second column has become the second row. Now once we get the A transpose, let us focus on A plus A transpose. Now since the orders of both A and A transpose are same, we are going to do the element by element addition. So 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5 is 11, and 7 plus 7 is 14. Now once we have got the A plus A transpose, let us find out the transpose of this entire term. So taking the transpose of this A plus A transpose, the first column becomes the first row and the second column has become the second row. So comparing A plus A transpose and its whole transpose, we can see that both the matrices are same. So now we can say that A plus A transpose is equal to A plus A transpose the whole transpose. Hence verified that A plus A transpose is a symmetric matrix. Now let us move on to the second sub question. We have to verify that A minus A transpose is a skew symmetric matrix, which means that we have to first find out A minus A transpose and then find its whole transpose and see if the transpose elements are opposite sign as that of this original matrix. So here we have taken again the A and A transpose elements, and performing the subtraction we get 1 minus 1 is 0, 5 minus 6 is minus 1, 6 minus 5 is 1 and 7 minus 7 is 0. Now let us take its whole transpose. So A minus A transpose the whole transpose. Now the first column has become the first row and the second column has become the second row. So here we can see that the diagonal elements are 0 for the original matrix and the transpose matrix. And the second observation is the signs have changed. So minus 1 has become plus 1 and plus 1 has become minus 1, which verifies that A minus A transpose is a skew symmetric matrix, hence verified. Now let us move on to the ninth question. Find 1 over 2 times A plus A transpose and 1 over 2 times A minus A transpose when A is given by a 3 by 3 square matrix. So let us begin with the first part, that is 1 over 2 times A plus A transpose. So here we have written the A matrix given in the question, and A transpose is got by changing each column to each row. So first column has become first row, second column has become second row, and third column has become third row. Now once we have got A transpose, let us find out the elements of A plus A transpose. So here we have written A matrix plus A transpose matrix. Now since the orders are same, we are going to perform element by element addition. So 0 plus 0 is 0, A plus and minus is minus, so A minus A is 0, so B plus and minus is minus, so B minus B is 0, minus A plus A is 0, 0 plus 0 is 0, C plus and minus is minus, so C minus C is 0, minus B plus B is 0, minus C plus C is 0, and 0 plus 0 is 0. So A plus A transpose we have got it as 0. Now let us see what is 1 over 2 times A plus A transpose. Now here 1 over 2 is a scalar quantity which multiplies with A plus A transpose matrix. So 1 over 2 times multiplies with each element of this matrix, which is a 0. So 1 over 2 times with 0 gives us 0 matrix. So here we have the value of 1 over 2 times A plus A transpose as a 0 matrix, since all the elements are 0. Now let us focus on 1 over 2 times A minus A transpose. So here we have taken A and A transpose and we have subtracted the two matrices element by element. So 0 minus 0 is 0, A minus of minus is plus, so A plus A is 2A, B minus of minus is plus, so B plus B is 2B, minus A gives us minus 2A, 0 minus 0 is 0, C minus of minus is plus, so C plus C is 2C, minus B is minus 2B, minus C is minus 2C, and 0 minus 0 is 0. Now once we have got A minus A transpose, let us find out 1 over 2 times A minus A transpose. Now again 1 over 2 is a scalar quantity, so it multiplies with each and every element of this matrix. So 1 over 2 times 0 is 0, 1 over 2 times 2A, the 2 divides each other from the numerator and denominator, giving us A. Similarly, wherever we have 2 or minus 2, the numerator 2 divides the denominator 2, giving us the elements as 0, A, B, minus A, 0, C, minus B, minus C, and 0. So these are the elements of 1 over 2 times A minus A transpose. Now let us move on to the 10th question. Express the following matrices as the sum of a symmetric and a skew symmetric matrix. So to understand this question, let us refer to a theorem, which is any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix So if we consider A to be a square matrix, then we can write it in terms of symmetric and skew symmetric matrix as matrix A is equal to 1 over 2 times A plus A transpose. Now this represents the symmetric matrix plus 1 over 2 times A minus A transpose. So A minus A transpose represents the skew symmetric matrix. So basically here we have to show that when we add the symmetric and skew symmetric matrix, we are going to get back this given matrix. So let us start with the first sub question. So here we have taken the first matrix and considered it as A. So let A be equal to 3, 5, 1 and minus 1. Now since we need the A transpose over here in the formula, we have found out A transpose by changing the column of A as row. That is, first column changes to first row and second column changes to second row. Now once we have got A transpose, let us focus on first part of the formula, that is A plus A transpose. So here we have written A plus A transpose. Now since the orders of these two are same, we are going to perform element by element addition. So 3 plus 3 is 6, 5 plus 1 is 6, 1 plus 5 is 6 and minus 1 plus minus 1 is minus 2. Now let us find out 1 over 2 times A plus A transpose. So here we have written 1 over 2 times A plus A transpose is equal to, now 1 over 2 multiplies with all the elements of this matrix. So 1 over 2 times 6 gives us 3. Again we get a 3 here and the third element is also 3. Now 1 over 2 divides itself, giving us minus 1. So we have got the first part of this formula and let us consider it as equation 1. Now on a similar basis, let us find out A minus A transpose. So here A minus A transpose. Now 3 minus 3 is 0, 5 minus 1 is 4, 1 minus 5 is minus 4 and minus 1 minus of minus is plus. So minus 1 plus 1 is 0. Now once we have got this, let us find out 1 over 2 times A minus A transpose. So here 1 over 2 multiplies with all the elements of this matrix. So 1 over 2 times 0 is 0. 1 over 2 times 4 is 2, 1 over 2 times negative 4 is negative 2 and 1 over 2 times 0 is 0. Now we have got second part of this formula. So here we have reconsidered the formula. So it is going to be the first matrix plus the second matrix. So here let us see if we add these two matrices, we get back the original matrix A. So here we had 3, 3, 3 and minus 1 plus 0, 2, minus 2 and 0. So when we add this, we are going to get 3 plus 0 is 3, 3 plus 2 is 5, 3 minus 2 is 1, minus 1 plus 0 is minus 1. Now this was the original matrix which was given in the question. So you do not have to show that when you add these two you are going to get this back. So this is going to be your answer. So you have shown that the given matrix can be represented as a sum of symmetric matrix and skew symmetric matrix. Now on a similar basis, let us find out the second sub question. So here we have considered the formula again and this is the A matrix. So we have found out the A transpose, that is the first column has become first row, second column is second row and third column is third row. Now once we have got the A transpose, let us find out A plus A transpose. Now here we have written A plus A transpose matrices. Now since the orders are same, we are going to perform element by element addition. So I am going to show the addition for the first row. So 6 plus 6 is 12. Minus 2 plus and minus is minus. So minus 2 is going to give us minus 4 and 2 plus 2 is 4. Similarly, we find out the elements of the second row and the third row. Now once we have got the elements of A plus A transpose, let us multiply it by 1 by 2. So here every element of A plus A transpose multiplies with 1 over 2. So basically every element is getting divided by 2, giving us this matrix. So let us consider this as 1. Now once we have got the first part of this formula, let us focus on the second part, that is by getting A minus A transpose. So here we have taken A minus A transpose. Now subtracting these two matrices, we get the 0 matrix. Now once we have got this, we have to find out 1 over 2 times A minus A transpose. Since A minus A transpose, we have got it as a 0 matrix. Now 1 over 2 times A minus A transpose is also going to be a 0 matrix. Now finally we have to plug in these two values in the above formula. So here we have reconsidered the formula, that is 1 plus 2. So the first matrix plus the second matrix. Now when you add element by element, you're going to get the given matrix. So here you have to show that matrix A can be represented as the sum of the symmetric matrix and skew symmetric matrix. So this is our answer. Now let us move on to the third sub question. Now this is the third sub question where the matrix A is again a 3 by 3 square matrix. So you can pause the video and give it a try. Try to find out A plus A transpose, A minus A transpose, and try to fit in this formula. So in the first step we have taken the A transpose. So the first column becomes the first row, second column becomes the second row, and third column becomes the third row. Now the next step is finding out A plus A transpose. So A plus A transpose, we have done element by element addition. Now once we have got A plus A transpose, we are going to find out 1 over 2 times A plus A transpose. So basically every element of this matrix gets multiplied by 1 over 2. So here we have got this matrix. So let us consider this as 1. So you can pause the video over here and check if you have got the same elements for 1 over 2 times A plus A transpose. Now the next step is finding out A minus A transpose. So here we have written A minus A transpose. So these are the elements we get after subtracting these two matrices. Now taking 1 over 2 times A minus A transpose, we get these elements, that is 1 over 2 multiplies with each element of this matrix. So you can pause the video over here as well and check the elements you have got for 1 over 2 times A minus A transpose. Now once you have got these two matrices, let us again consider the formula and plug it in over here. So here we are going to get the matrix A as the sum of the symmetric matrix and the skew symmetric matrix. So basically if you want to verify if you have got the correct answer or no, just add element by element these two matrices. So you should get back the original matrix, that is this matrix. So if you have got the same elements, then you have got the correct answer. Now let us move on to the fourth sub question. Now this is the fourth sub question. This is a 2 by 2 square matrix. So we are going to first find out A transpose. So the first column becomes first row and second column becomes the second row. Now once we have got A transpose, the next step is to find out A plus A transpose. So adding these two matrices, we get this value. So the next step is 1 over 2 times A plus A transpose. So basically 2 divides each and every element of this matrix, giving us this matrix. And let us consider this as 1. Now the next step is finding out A minus A transpose. Now the subtraction between these two matrices gives us this matrix. So taking 1 over 2 times A minus A transpose, we get the matrix as 0, 3, minus 3 and 0. And let us consider this as 2. Now finally taking this formula, we have 1 plus 2. So this represents the symmetric matrix which we got, that is 1, plus this is the skew symmetric matrix. So when you add these two, you are going to get the original A matrix. So here this is going to be our answer. So if you are trying it on your own, pause the video and check the values of the elements you have got. Now let us move on to the next question. Now question number 11 and 12 are multiple choice questions. If A and B are symmetric matrices of same order, then AB minus BA is a. So here we have been given that A and B are symmetric matrices. So we can write A transpose is equal to A and B transpose is equal to B, because this is one of the properties of the symmetric matrices. So the given matrix has to be equal to the transpose of the same matrix. Now once we have got this, let us say that AB minus BA is a symmetric matrix. So if it is a symmetric matrix, then this matrix has to be equal to its transpose. So let us find out its transpose now. So here we have taken the given expression is equal to AB minus BA transpose. Now in the next step, we have used one of the properties of transpose of a matrix, where the transpose gets distributed to each term within the bracket. That is, the transpose goes to AB minus the transpose goes to BA. Now in the next step, another property of transpose of a matrix is used, where when we take the transpose of product of two matrices, the transpose gets distributed as B transpose comes first multiplied with A transpose minus, now the transpose of the second matrix comes first, that is A transpose times B transpose. Now here we have already got A transpose and B transpose as A and B. So substituting in place of B transpose and A transpose, we get BA minus AB. Now here we have taken AB minus BA, but we got BA minus AB. Now let us take the minus as a common factor. So when we take the minus out, we get AB minus BA. which means AB minus BA is equal to the negative of AB minus BA. So this is the property of skew symmetric matrix. So here we have written, since AB minus BA is equal to minus AB minus BA, it is going to be a skew symmetric matrix. So here our answer is going to be A. Now let us move on to the last question. If A is a 2 by 2 trigonometric matrix and A plus A transpose is equal to identity matrix, then the value of alpha is. So here let us consider the given expression, that is A plus A transpose is equal to identity matrix. So here we have taken the expression and this is the A matrix and we have taken its transpose. That is, the first column has become the first row and the second column has become the second row. Now on the left hand side we have written A plus A transpose matrices is equal to identity matrix is going to be 1 0 0 1. Now since both are of the order 2 by 2, we are going to perform element by element addition. So here we get cos alpha plus cos alpha minus sin alpha plus sin alpha. Sin alpha plus and minus is minus. So sin alpha minus sin alpha and cos alpha plus cos alpha is equal to 1 0 0 1. So we can simplify the left hand side matrix. That is, the first element will add up together. That is, cos alpha plus cos alpha is 2 cos alpha. Now minus sin alpha plus sin alpha will add to give us 0. Now third element will also add up to give us 0. And the fourth element is cos alpha plus cos alpha giving us 2 cos alpha is equal to 1 0 0 1. Now using the law of equality of matrix, we can equate the first element with the first element of identity matrix because both are of the same order. So here we have written 2 cos alpha is equal to 1, or taking 2 on the other side we get cos alpha is equal to 1 over 2. Now let us take cos on the other side of equal to sine, so we get alpha is equal to cos inverse of 1 over 2. Now this is inverse trigonometric ratio, that is cos inverse of 1 over 2 is going to be pi over 3, or in degrees it is going to be 60 degrees. So here the value of alpha is pi over 3. So let us see if it is in the options above. So it is option B, that is pi over 3. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out these playlists where you will find more examples of this kind. And if you are liking my videos, like, share and subscribe to my channel. And thank you for watching.